chemical reactions of amines. Next reaction, fifth one, reaction with aryl sulphonyl chloride. Reaction with aryl sulphonyl chloride. Aryl sulphonyl chloride, for example, benzene sulphonyl chloride. Amines reacts with benzene sulphonyl chloride. Benzene sulphonyl chloride. That is C6H5SO2Cl. C6H5SO2Cl. So amines reacts with C6H5SO2Cl, which is known as, this compound is known as Hinsberg reagent. Hinsberg reagent. And form sulfonamides. The product obtained will be sulfonamides. Okay. So different amines reacts in different manner. Okay. First, primary amines. Primary amines. So primary amines on reaction with benzene sulphonyl chloride and form N-ethyl benzyl sulfonamides. Let us see the reaction. C2H5NH2. Okay, on reaction with benzene sulphonyl chloride. Okay, SO2Cl. C6H5SO2Cl. Reaction takes place and the product will be C2H5NH. One hydrogen atom is replaced by SO2C6H5. Okay. And the product, the name of the product is N-ethyl benzene sulfonamide. Okay. N-ethyl benzene sulfonamide. This will be the reaction. Okay. Since this SO2 group, this sulphonyl group is highly electron withdrawing. Okay, this is highly electron withdrawing. So hydrogen will be acidic in nature. So hydrogen atom is replaced by potassium on reaction with alkali KOH. Okay, on reaction with alkali, this hydrogen atom is replaced by K plus. Okay, due to the presence of sulphonyl group, which is highly electron withdrawing. Okay, and the product will be C2H5 N minus K plus SO2C6H5, and the product obtained will be soluble in alkali. Okay, this is an important reaction for the to distinguish primary amines, secondary amines and tertiary amines. Let us see the reaction with other compounds, okay, like secondary and tertiary amines. Okay, so on reaction with alkali, N-ethyl benzene sulfonamide, on reaction with alkali, the product obtained is soluble in alkali. Okay, now let us see the next reaction with secondary amines. Secondary amines. Okay, so C2H5 diethyl amine on reaction with benzene sulphonyl chloride. Okay, C6H5SO2Cl, and the product will be C2H5 twice NSO2C6H5. Here, this compound does not contain any acidic hydrogen atom. Okay, so the product will be NN diethyl sulfonamide. Okay, so we can say that if we are adding alkali, the product will not be soluble in alkali. That means the product does not contain hydrogen atom attached to the nitrogen. It is not acidic and it is insoluble in alkali. Insoluble in alkali. Okay. Now, what about the second tertiary amines? Tertiary amines will not give any reaction with benzene sulfonyl chloride. No reaction with benzene sulfonyl chloride. So, this is an important reaction for the separation of primary, secondary and tertiary amines. Okay. Important reaction for the separation of primary, secondary and tertiary amines from their mixture. Also, it helps to distinguish primary, secondary and tertiary amines. Okay. Okay. But nowadays, instead of benzene sulfonyl chloride, nowadays we are using para-toluene sulfonyl chloride. Okay. Para-toluene sulfonyl chloride is used. Okay. Next, sixth reaction, reaction with nitrous acid. Nitrous acid is HNO2. Nitrous acid, HNO2. Okay. HNO2 is highly unstable. So, it is produced in situ. In situ means it is freshly prepared during the reaction. Okay. Freshly prepared during the reaction. It can be prepared from NaNO2 and HCl. Okay. NaNO2 reaction with HCl gives HNO2 and NaCl. Okay. So, HNO2 can be produced in situ. Okay. Different amines reacts in different manner with nitrous acid. So, this is an important reaction to distinguish primary, secondary and tertiary amines. Distinguish primary, secondary and tertiary amines. Okay. Let us see the reactions one by one. First one, reaction with aliphatic primary amines. First reaction, in the case of aliphatic primary amines. Okay. Aliphatic primary amines. Example, C2H5NH2 on reaction with HNO2. It's produced in situ from NaNO2 and HCl. Okay, and the product will be a diazonium salt. C2H5N2 plus Cl minus. This is highly unstable. Okay, so on hydrolysis, from this nitrogen gas is evolved and form alcohol C2H5OH plus N2 plus HCl. So, this reaction is used for the quantitative, so from this quantitative evolution of nitrogen gas takes place. We can quantitatively measure the nitrogen gas obtained, which is used for the estimation of amino acids and proteins. Okay, used for the estimation of amino acids and proteins. Okay, this is in the case of aliphatic primary amines. Next, aromatic primary amines. They will react in different manner. Aromatic primary amines. Okay. Here, the aromatic primary amines reacts with HNO2, nitrous acid, and form diazonium salt, which is an important product for the preparation of variety of aromatic compounds. Let us see the reaction. And the reaction takes place at very low temperature of 273 to 278 Kelvin. Reaction takes place at 273 to 278 Kelvin. Okay, let us see the reaction. Aniline, aromatic primary amine, on reaction with NaNO2 and HCl. that is HNO2 is produced. At a temperature of 273 to 278 Kelvin, what will happen? Diazonium chloride is obtained, N2 plus Cl minus, and this reaction is known as diazotization reaction. Okay, diazotization reaction. Okay, and this compound is used for the synthesis of variety of aromatic compounds. And if the temperature is raised above this temperature, what will happen? This decomposes to phenol. Okay, above this temperature, it decomposes to phenol. Okay, next case. In the case of secondary aliphatic amines and aromatic amines. Secondary aliphatic amines and aromatic amines. What will happen? Okay, here with nitrous acid, it produces nitrous compound. Let us see the reaction. C2H5 twice NH. Secondary amine, aliphatic amine. On reaction, it gives with HNO2. Okay, it gives C2H5 twice NO plus H2. This compound is N-nitroso diethylamine. Okay, N-nitroso diethylamine is obtained. Okay, this compound is insoluble in aqueous solution. Insoluble in aqueous solution. Okay, and forms an yellow layer. Okay, this forms a yellow layer. Separate yellow layer is obtained. Okay, now this is the distinction from primary aliphatic amines. Okay, so there is an important test for this reaction, which is called as Lieberman's reaction. Lieberman's nitroso reaction. Okay, this test is used to identify secondary aliphatic amines or distinction from primary and tertiary amines. Okay, this nitroso compound obtained is when warmed with a crystal of phenol. Okay, a crystal of phenol and a little sulfuric acid is added. Concentrated sulfuric acid. Little concentrated sulfuric acid is added. What will happen? It produces a green color. Okay, or green solution is obtained. Okay, this green solution turns blue on adding an alkali. Okay, this is an important test for secondary amines. Okay, so first nitroso compound on a reaction with nitrous acid forms nitroso compound. This embalmed with crystal of phenol or a little concentrated sulfuric acid produces a green solution. Okay, it turns blue on adding alkali. Okay, now next is what will happen in the case of tertiary amines. Tertiary amines. Tertiary aliphatic amines. Tertiary aliphatic amines gives a salt which is a nitrite. Okay, forms nitrites which is a salt. Let us see the reaction. CH3 thrice N reaction with HNO2 gives CH3 thrice NH plus and NO2 minus. This is a salt called triethyl ammonium nitrite. Trimethyl. It's methyl group. Okay, trimethyl ammonium nitrite is obtained. This is in the case of tertiary amines. Okay, in the case of aromatic tertiary amines, what will happen? Electrophilic substitution takes place. Okay, aromatic tertiary amines, what will happen? In this case, they undergo substitution, electrophilic substitution at the ring. Let us see the reaction. N CH3 twice. Okay, this is NN dimethyl. NN dimethyl aniline. 2 hydrogen atoms are replaced by 2 methyl groups. Okay, in the case of aniline. So, what will happen on reaction with HNO2? Here, NO group is in the ring. Okay, the electrophilic substitution takes place in the ring. Here, like this, twice, plus H2O. That is para-nitrous or NN dimethyl aniline. Okay. So different compounds give different products. So this is an important reaction, that is reaction with nitrous acid is an important reaction for the distinction between different amines. Okay, different amines. Okay.